All right, 10.4 is going to talk about a topic that you may or may not have seen before. And initially, it's not going to look related to what we've been doing, but I promise the connection will come very quickly. Okay? This is called Pascal's triangle. Pascal's triangle is an unending triangular array of numbers. It was written about by Pascal in 1653, but evidence shows that it was studied in China and India as early as 1100 or possibly earlier. So Pascal sort of gets credit, but he wasn't the first one to do it. That is not the only time in mathematics that happens, by the way. There's several places where that happens. Okay, as I start drawing in this triangle, try your best to keep things straight. Okay? Straight across the lines. If you want to draw lines themselves to try to keep yourself sort of horizontally on a line, that might be helpful. So Pascal's triangle has a 1 at the top of it. And then on either side of it, sort of underneath, there's a couple more 1s. And I'm going to write in about 4 or 5 rows, and then we're going to stop, talk about the pattern, and then we'll continue by using the pattern to create the next rows. So the third row is 1, 2, 1. The next one is 1, 3, 3, 1. And then 1, 4, 6, 4, and 1. I'm going to pause there. Oh, actually, let me do one more. I think it'll be more obvious if you do just one more. We'll do 1, 5, 10, 10, 5, and 1. Let's do that. Okay, so somebody pick, not a number 1, any other number in my picture. 6. Okay, so here's a 6. This 6 has above it, at the angles, 2 3s, correct? What is 3 plus 3? 6. Okay. We can create and continue to create lines of this triangle using that pattern. The outer edges are always 1s. The inner edges are always the sum of the 2 values above it. So if we think about it from that perspective, I have a 1, and then I have 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 6 and 1. And you'll notice there's, of course, symmetry, right? Once you get to sort of the halfway point, it starts repeating itself on the other half side of the triangle. So let's create, we're going to go down to row 8. That's how far I want to go down based on the questions that I'm giving you. But it is unending, which means this could go on, well, not could, it does go on forever, right? This pattern will go on forever. My next row would be a 1 and then a 7, and then what? 21, and then 35, and another 35, and then 21, 7, and 1. And the last one we're going to write down together is going to have a 1 and then an 8. And then what? 28, 56, 70, 56, 28, 8, and 1. Okay, everybody good? So far, so good. Okay, so push pause on this, and then we're going to actually take a look at something else, and then I'm going to connect them, okay? So I'm switching slides. This is the bottom half of this page 1 that you have. And we're going to write out another triangle. This is a triangle that has combinations in it. I'm going to start at the top of the triangle with 0, C0. And then I'm going to write 1C0, And on the other side, I've got 1C1. And then I'm going to have 2C0, In the middle is 2C1, and on the outside is 2C2. I'm not going to go all the way down to 8, by the way. We're going to stop a little bit sooner than that. We're going to do 3C0, 3C1, 3C2, 3C3, and then 4C0, 4C1, 4C2, 4C3, 4C4. And we're going to do just one more. 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. Okay. These are combinations. You've seen this notation. We just did a whole bunch of examples and the stuff. So you've seen this notation before, and it means the same thing we used it for before. Okay, do you see the pattern in me writing down all the 5s and 4s and 3s and 2s and 1s and 0s and all that stuff? Did you see the pattern? Right? Okay, there is, yeah. And so what we're going to do is we're going to label these rows in a little bit of a strange way, but it's going to be obvious in a moment why we need to. We're going to call this first row, row 0. And then the next one's going to be row 1. And then I'm going to have row 2, row 3, row 4, and row 5. Whoops, 5. So in some sense from here, you can kind of see why I've called them the rows that I have, because they match the number of this that's in front of the C on that row, right? So like on row 4, it says 4C0, 4C1, 4C2, 4C3. Everybody see that? Okay. So over here, I want us to label our rows the same way. Row 0 down to, in this case, it'll be row 8. So we're going to call these, same as before, row 0, row 1, 2, 3, 4, 5, 6, 7, and 8. And again, you can see why that's sort of desirable on these, because there's an 8 in row 8, and there's a 5 in row 5, and there's a 3 in row 3, and so forth, right? But here's the cool connection. Somebody choose a random number in my table in rows 5 and up, because I don't have rows further than that on the other one. Choose one for me. Pick a number. 35. Okay, I need something in rows 5 and up. 35 is too low. 10, thank you. I'll use this first 10, but we could use the second one if you want. Okay, so in this location, I'm on row 5 and it's the third entry, right? This is row 5 and it's entry 1, 2, 3. So over here, if I go to row 5 and I go to the third entry, I'd be right here. Everybody with me? Let's calculate 5C2. You know how to do it. We've been doing several of them. 5C2 says I do 5 factorial. I've chosen 2 factorial over them. I haven't chosen as well 3 factorial. Looks like this. So this is 5, 4, 3 factorial over 3 factorial, and then 2 times 1. 3's cancel. If you want to do the multiplication, you can. If you want to reduce, you can. What number does this give you? The same one we started with over here in the location. Every single one of those numbers is a combination. So what does that mean? Well, it means if you don't have too big of a number at the front, you can actually do this using Pascal's triangle instead of doing it with formulas. So over here, when it says 6C3, I can come back over here. I'm on row 6, and I need to do the third entry after the number 1, okay? The number 1 on the outside are considered the 0 entries. So I skip that one when I'm counting. So I'm on row 6. I skip the number 1. I count 1, 2, 3. The number is 20. And I'm done. It's good, right? How about 8C6? Well, go down to row 8. Skipping the number 1, count over 1, 2, 3, 4, 5, 6, and you get the number 28. This is 28. I don't know about you, but I don't want to write this out to 52 factorial stuffs, right? That's what we were doing with our cards examples. But I have had students write it out further than row 8 and felt like that it was worth their time to do so. So you could take this and write it out further if you wish, and that'll be fine. We're going to do it with some examples where we've actually got some context to finish out this section. We're creating a committee. I mentioned this back when we were looking back in a little bit, section in 10.3. Committees mean combinations because the order doesn't matter on a committee. So we are working with combinations. Notice Pascal's triangle works for, good grief, combinations, right? So everything inside of 10.4 is going to be a combination problem. That's sort of a nice feature. It says that we have 3 people on our committee. So it's a committee of 3. And we're selecting them from 7 women and 3 men. Okay, so there's 7 women and 3 men that are being picked from to be on this committee. How many ways are there going to be to get exactly 3 women? Well, I want to choose 3 women, but how many women do I have to choose from? 7. So this is 7C3. All righty. Go to row 7. It's 35. All right, remember, don't count the number 1. Somebody's just tempting to start there at the beginning. Don't count the number 1. 1, 2, 3 puts me at the 35. There are 35 different options for this. How about exactly 3 men? How many men are there to choose from? 3, and I want all 3 of them. You may flat out know that number, but if you don't, you can come back over here. Row 3, it's the very ending 1. What are you going to do on 5 when it says exactly 1 woman? 7C1. Okay, so 7C1 puts 1 woman on the committee. Have I created the whole committee, though? No, that's just 1 person on my committee. This is like having my four jacks in my hand, and I need 1 more card. So I've got 1 person on the committee. I need 2 more people. But the only other category is men, so I have to choose from the men that I have. So I need to choose 2 more people from among how many men were there? 3. So it's a fundamental principle of counting using combinations. 7C1. What's 7C1? 7. And what is 3C2? So row 3, skip the 1 column, entry 2 is a 3. So there's 21. How about exactly 1 man? How do I get 1 man to be on this committee? 3C1. There's 3 men to pick from and I pick 1. But that is not my whole committee. What else do I need? 7C2. I need to finish out my committee. These numbers at the end here are my committee members. I've got 1 of them and I've got 2 of them. That's a total of my 3. 3C1. Row 3. First entry, that's not the number 1, it's a 3. So I get another 3. And then 7C2. Yep, 7C2 puts me at the 21 right here. And 3 times 21 is 63. Clever, right? Very clever.